video, we're going to look at gravitational potential energy. This is a super easy concept, super easy math because you're multiplying. The only difficult thing is have to multiply by a decimal. So let's get into this right away. What is potential energy? Well, first of all, what is energy? Energy is the potential to do work, and the definition of work is force through a distance. So potential energy is the potential to do work. So therefore, gravitational potential energy is the potential to do work based on the force that is created by gravity. All right, so let's talk about what is the force created by gravity. Well, we normally call that weight, and in the English system, we measure that in pounds. So when we step on a scale, the force of our mass being accelerated by gravity creates a force called weight. All right, so in the metric system, it's going to be in newtons, and it's going to be kilograms is going to be our mass unit. So we're going to take the number of kilograms, and we're going to take then the rate of acceleration due to gravity, and that's going to give us the force. We're going to call that weight. So the weight is going to be the acceleration due to gravity times the mass. Now, acceleration due to gravity is a constant that is based on whatever planet you're on. So if you're on the moon, your weight is less, you've heard this many times, than if you were on Earth. But if you're standing on the sun, that's not really possible because you'd be, melted. But if you were, your weight would be much greater. The moon has less mass than Earth. The sun has more mass. So now, force through a distance. Distance is going to be real easy. Distance is something you're going to measure. We're going to measure it in meters because we're going to be using joules and newtons and kilograms. So we're going to say how high the object is the amount of space that it can move, and that space is going to be the distance. So we go back to work equals force times distance, where force is the weight and weight is the mass times acceleration due to gravity. So we use a special letter to indicate acceleration due to gravity, that's g. So the amount of work that could be done is the distance that it can travel and the force mg, mass times acceleration due to gravity. So mg times h is going to give us the potential work that can be done, because work is force, weight, distance, height. So how far it can fall. So if we were to take an object, this piece of metal, and we were to attach a string to it, then the distance from here to the surface, that is the amount of distance that it could travel, and its weight in newtons is the force that it could apply. Quick example. An object has a mass of 10 kilograms, and it has the ability to travel. So the height the object is above the surface is 5. So first we're going to do is we're going to take the mass of the object, 10, and we're going to multiply that by the acceleration due to gravity. We're going to use 9.8 times 9.8. I can do that in my head. 98 newtons is the force. And the distance that it can fall is 5 meters. So we have a potential energy of mg, 98, times 5, 490. So it has the potential of 490 joules of energy. That's just how easy it is. All right, really super simple concept. Potential gravitational energy is the amount of energy that can be done based on an object's position above the Earth or whatever planet you're on. And it's going to be found using the equation mass times acceleration due to gravity times the height, where height represents the distance through which the force, which is weight, can be applied. Applied force through a distance is work, and potential energy is the potential to do that work. Now we've full circle back around. That's it. Hopefully this is helpful. Please click the like button, subscribe to the channel, sign up for notifications, all those sorts of things. That is all. We'll see you in the next episode.